Alright, let's go ahead and start Chapter 6, which is our bonding, the beginning of our bonding unit. And the first thing we're going to talk about are compounds. And a compound is when you take two or more elements and you combine them chemically. And the forces that hold those two elements together so that the compound can stay together, they're called chemical bonds. Now, once you have a lot of chemical bonds throughout a compound, you then have a chemical structure. And so the different compounds have different chemical structures. A compound's chemical structure is the way the compound's atoms are bonded together. And just like the structure of buildings can be represented by blueprints, like an architect draws it all on blueprints before we actually see the structure of the building, the structure of chemical compounds can also be shown by models. Now, there are different models that will show different aspects of the compound. And the first type of models that we're going to talk about are those that show bond lengths and bond angles. And there are two models that can show bond lengths and bond angles. The first is the ball and stick model. This is where the atoms are represented by circles and the bonds that hold the atoms together are represented by lines. And you'll see a picture of one in your notes. Now, the bond length is the distance between the nucleus of the two bonded atoms. And what we say, instead of saying, we say nuclei when you're talking about two nucleus. Now, a bond angle is the angle that's actually formed by two bonds to the same atom. The compounds have to have three or more atoms to have a bond angle. So to actually have a bond angle, you have to have three or more atoms in your compound. And as you look at your picture, it shows you two of the angles for that ball and stick model. The second type of model that represents and shows bond lengths and bond angles is the structural formula. Now, a structural formula is similar to the ball and stick model, but it uses chemical symbols or the element symbols to represent the atoms instead of circles or balls. Now, but these also still show the structures of compounds. They just use the element symbols instead. Now, the next type of model actually is called a space-filling model, and space-filling models show how much space the atom takes up. And the space-filling model also shows the relative size of atoms in a compound, but it does not show bond lengths or bond angles. Now, bonds can bend, stretch, and rotate without breaking. And we need to talk about this, and we're actually going to draw a little picture in your notes so that we can remember, because when we look at these models, they're a little deceiving, because using the lines to represent chemical bonds, they look very rigid, like they wouldn't be able to bend, stretch, or rotate, but chemical bonds actually can. All right, so what I need you to do, right underneath that sentence that says bonds can bend, stretch, and rotate without breaking, I'd like you to draw a little picture. And these are going to be the two atoms. And usually what we show is we show, a line, and it looks very rigid going between the two atoms. But actually a bond really works like flexible springs. And so sometimes the atoms can be this close together, and then sometimes the atoms can be further apart because they can bend, they can rotate. And if you can just remember the flexible springs, that they look about like flexible springs, that will help you to remember that bonds can bend, stretch, and rotate. So just remember, the pictures on the right here are the more accurate representation of what a bond can do, because they act like flexible springs. The one on the left is how we draw them, but it can misrepresent exactly how a bond can move. Now, we've talked about that compounds have chemical structures. So how do these structures affect the actual properties of the compound? This is actually what determines the properties and tells us how a compound is going to act. And some of these compounds are made of network structures. There are three types of structures we're going to discuss: network structures, bonded ion networks, and molecular structures. Those are the three types of structures. So let's start with network structures. Compounds with network structures are strong solids, and you can see two pictures in your notes what they look like. And an example would be quartz, like the rock and that's also pictured in your notes. Now, the second type of network structure that we want to talk about is the bonded ion network. Okay, so far we've talked about two different types of structures, network structures, and now we're talking about bonded ion networks. And this is a network that is made of tightly packed, positively charged ions and negatively charged ions. Okay, that's why it's called the bonded ion network. It takes positive ions and negative ions and pulls them together. And so it's a strong structure, but it's not as strong as network. Network is the strongest type of structure we have. Then we move to bonded ion networks, which is next in line in strength. An example of that, like on your notes, if you'll see, is an example of sodium chloride, which is our table salt, and that's an example of a bonded ion network. The strong attractions between these oppositely charged ions is what gives it the strength and gives the structure that type of strength. And since it's very strong, it's going to have very high melting points and very high boiling points. Because when you have those chemical bonds, the stronger the chemical bonds are, the higher you have to have a temperature to melt it and make it boil. And so if it's easier to break, if it's a weaker chemical bond, then it's not going to take as high, it won't take as high of a temperature to break. But if it's very, very strong, it's going to have high melting points and high boiling points to break it. An example here is salt, like we discussed just a few minutes ago. And the last type of structure that we're going to discuss today is molecular structure, a compound that's made of molecules. This is the weakest structure. So on the side of your notes, make sure that you mark these in order of strength. Network structure is the strongest, then we have bonded ion networks, then we have molecular structure, and molecular structure is the weakest type of structure. An example is going to be water and sugar. And you'll see down here, this is an example of a water molecular structure in your notes. Now, molecules of sugar and water, they actually attract each other to form crystals. And so what happens is, if you'll see those kind of like dotted lines in your picture of underneath molecular structure, it's like they just kind of have a bond, but it's not a very strong bond. That's why the lines are dotted. And so these attractions are very weak, and so they create weaker bonds. And another thing to make sure you know about molecular structures, a lot of times it's between carbon, hydrogen, oxygen atoms. A lot of times it is. And those are all nonmetals, and so it creates a weaker structure because they're all nonmetals. When you have a nonmetal and a metal together, like sodium chloride, like we discussed earlier, it makes a stronger bond because of that attraction. So the strength of attractions between molecules vary. And we've talked about this. Stronger bonds require more energy to break the bond. Weaker bonds require less energy to break the bond. So I want you to think about this. Element A has weaker bonds than element B. Which one has the higher melting point? I'd like you to pause the video and write your answers in your notes and resume the video once you're ready. All right, the answer to this question, which one has the higher melting point? If element A has weaker bonds than element B, that means element B is the strongest, so it's going to have the higher melting point because it takes a higher temperature to break the bond. Now let's look at this question. Which have stronger bonds? Solids, liquids, or gases? Go ahead and pause the tape and resume once you're ready. Solids have the stronger bonds. They're the ones more tightly packed and have the stronger chemical bond than liquid or gases. All right, now it's time to summarize what we've learned today. So what I'd like you to do is I would like you to do a speed dating summary. I want you to set a timer for 2 minutes, and I want you to write as much as you can about what we've learned today in the 2-minute segment that you have on your timer. I hope to see you in class, and we'll work on this once you get there. Have a good evening.